Welcome students. Today we are going to discuss types of sets. It is very interesting topic and useful topic in the mathematics. Okay, let us start. Types of set. The first is null set. The set which contains no elements at all is called the null set. This set, sometimes called the empty set or the void set, it is denoted by the symbol phi or simply by the curly bracket. Okay, let me write a set having no element, right. It is also known as void set or empty set. Empty set and void sets are the other names of the null set, right. It is denoted by the symbol phi. Phi, or simply you are writing curly bracket without any element, right. If set is having at least one element, then that will not be null set. Okay, let me take an example. Suppose I am writing x, a is equal to x, where x square plus 9 is equal to 0 and x is a real number. So you know it very well that x square plus 9, if we solve it, then obviously if we solve it, x square plus 9 is equal to 0, then you have x square is equal to minus 9 and you have x is equal to plus minus 3i. It means no real value of x exists which will satisfy this equation. So this is a null set, this is a void set, this is an empty set, no element, it is having no element at all. No real number satisfy this equation. So this is a null set. Okay, is that clear? The next one is singleton set. A set having only a single element is known as singleton set. Suppose I am writing set A is equal to 5. Okay, if I write B is equal to x, x is smallest 3-digit number, digit number. So you know it very well, the smallest number is only unique digit number, that is 100. Smallest 3-digit number is 100. So this is also a singleton set. A set consisting of a single element is termed as singleton set. Is that clear? Okay. Next is finite set. A set is called a finite set if it is either void set or its element can be counted by natural numbers, and the process of listing terminates at a certain natural number n. Finite set means this is very simple. If number of elements in the given set are finite, 1, 2, 3, 4, 5, this is a finite set. Again I am writing set of bubbles, this is also a finite set because number of elements are finite. Means if we count these numbers, then that counting terminates at a particular point, at a particular natural number, right. And here one more term which I would like to introduce, that is the cardinal number of a finite set. Cardinal number of a finite set. Cardinal number means number of elements in the set. Suppose I am writing once again, let me write 1, 2, 3, 4, 5. So cardinal number of A, it is written as n of A is 5. It is also known as order of set. Right. So that is the cardinal number. We can also write it as order of set is 5. So it is known as cardinal number of the set. Is that clear? Okay. Next, infinite set. Infinite set means whose elements cannot be listed by the natural numbers, right? Or a set having infinite elements. Suppose I write A is equal to x, such that x is a real number. Then how many elements are there in set of real numbers? This infinite set, you cannot count each and every number, right? One more, I am writing it. Suppose I am writing a GP. 1, 2, 4, 8, 16, ... So this is infinite set. Where will this GP terminates if ... is there? Nowhere. So this is infinite set. Okay. Next, equivalent set. Two sets A and B are said to be equivalent if their cardinal numbers are same. What I spoke, two sets are equivalent. Two sets are equivalent sets. provided that their cardinal numbers are same. Suppose we are considering set A and we are considering set B. So, their order is same, or number of elements in A is equal to number of elements in B. Cardinal number is same. Cardinal number, earlier we have discussed, you understand it, cardinal number. We will make it clear with the help of example. Let me take example. Suppose I am considering 1, 2, 3, 4. The order of A is 4, or cardinal number of A is 4. One more set I am taking. Suppose I am writing 4, 8, 16, 32. So, both the sets are of same order. Order of set B is also 4. This is set B is also 4. So, their order is same. If order is same, they are said to be equivalent set. Their cardinal number is same. They are said to be equivalent set. Okay. Now, the next one is equal sets. Two sets A and B are said to be equal set if every element of A is an element of B, and also every element of B is an element of A. And B, right? Equal sets means, suppose I am writing A is equal to 1, 2, 3, 4, and B is equal to, again I write 4, 2, 1, 3. So, every element of set A is an element of set B. Similarly, every element of set B is an element of set A. So, such sets are said to be equal sets. Even if I have repeated earlier, I have discussed it in my previous video. You can see my previous video by clicking on the I button. Suppose I write, so repetition of the element is not going to change the set. They are same set, right? They are same set. Okay, A and B. So, in equal sets are always equivalent sets. Equal sets are always equal sets, equivalent sets. Why? Because their cardinal number is same, but equivalent sets may not be equal sets, right? We are moving to the next one, that is universal set. This is very important. It is denoted by U, universal set. A set consisting all the sets under consideration, all the sets under consideration. Is known as universal set. Okay, I will take an example. Suppose I am taking x is a natural number, right? Another set B I have taken x such that x is a integer. Another set I have taken x such that x is a rational number. We can denote it by any symbol like P. So, here you can see we are considering three sets A, B and C, right. A is having all the elements and all the elements which belongs to set of natural numbers. B is having all the elements belonging to the set of integers, and C is having the rational numbers, right. So, here universal set will be the set of real numbers. Universal set U, this is the set of real numbers x such that x is a real number. Because if x is a real number, it will be a rational number, it will be an integer, it will be a natural number. So, a set that contains all the sets under consideration is called the universal set, and it must be kept in the mind. I have seen there are some students who have a misconception in the mind. Universal set is not unique. If you are considering the set of numbers, then the set of real number has become the universal set, but if you are considering something else, then it will change. So, universal set, it's not a unique set, it may be different in different problems, right. It may be different in different problems. Again is power set. If S is any set, then the family of all the subset of S is called the power set, and it is denoted by P of S. Here I am writing P of S. P of S is equal to, let me write, suppose this is T and T is subset of S. You know, to understand it, let me take an example. Suppose I am taking an example, if I have a set and the elements are only 1, 2, 3, then all the possible subsets, I will be writing all the possible subsets. Then power set is the set having all the possible subsets. So phi is subset of every set. Then 1 is also a subset, right? We will be writing 1. Then 2 is also a subset of S. 3 is also a subset of S. 1, 2, this also a subset. 2, 3, this also a subset. Then 1, 3, it is also a subset. And 1, 2, 3, 1, 2 and 3, this also a subset. So a set having all the subsets of given set is known as power set. A set having all the subsets of given set is known as power set, right? If A is equal to phi, then how many subsets this phi has? It has 1. So then power set will have only one element, and that is phi. So number of elements in power set of A is 1. It means power set is always non-empty, right? Now one more thing which you must keep in the mind, just count the number of elements. Here number of elements are 1, 2, 3, 4, 5, 6, 7, 8. So if a set has n element, this is very important point, n elements, you must remember it, then power sets have 2 to the power n elements. If n elements are there in a given set, then power set is having 2 to the power n elements. 3 elements are there in S, then power set is having 8 elements. If set S is having 2 elements, then power set will have 4 elements. If set S is having 5 elements, then power set will have 2 to the power 5 elements. Is that clear? Okay. Now the last one is subset. Let A and B, this is very simple to understand. Let A and B are two sets. Let A and B, let me make it B, are two sets such that every element of A belongs to B. Every element of A is an element of B. Then A is called subset of B, and we write it as A is subset of B. To make it clear, I will take example 1, 2, 3, 4. This set B. I am taking A is equal to 2, 4. You can see every element of set A is an element of set B. So how many subsets it can have? Phi is also a subset of B. Phi, the null set is also known as, because null set is having no element, right? So how many subset it may have? The number of element in power set, that will be 2 to the power n, right? Is that clear? So every set is also a subset of itself. If I write B is equal to, B dash is equal to, or B is equal to 2, 3, 1, 4. So B is also a subset of B. The empty set, this is an important point, the empty set is also a subset of every set. The total number of subset of a finite set containing n elements is 2 to the power n. I told you earlier, if it is having n elements, the number of subset will be 2 to the power n. Okay, that's all. Thank you very much for watching this video. Please like this video and share this video. If you have any doubt, any query, any question, please write in the comment section. And if you are looking for video on any topic of your choice, do mention in the comment section. I will be delighted to answer your queries. Once again, thank you very much. Jai Hind, Jai Bharat.